All right, you unruly grade 10s. Here are a few of your homework questions that I will help you with.
Let me start.
Are you ready? This is Foundations Math 20, section 8.3 on scale diagrams. So I'm going to do question 1, 2, and maybe 4, I think, with you here, just to get you started. So, determine the scale factor that's used to transform diagram X, so this is original, into diagram Y. Express your scale factor as a fraction and as a percent. Woohoo! No problem. Percent is just 100 times the fraction, or the decimal form, right? So X, let's see. A corresponding side to this side would be this one over here. So I'm going to measure both of those. I have 1, 2, 3, 4, 5. This is 5 units, and this is 1, 2, 3. Okay? Now this is my original, so my scale factor puts the diagram measurement over the original, right? 3 over 5. Okay? So there's your fraction. Now, the percent, you could just do this on your calculator. 3 divided by 5 and then hit a percent button, I think, maybe. I don't know. I never use a percent button. But 3 over 5 is what is a decimal? 0.6, right? 246. Each one out of 5 is 0.2. So 246, which is, as a percent, that is 60%.
Crazy.
Isn't that awesome? Well, you look at that. Now, there are no sides in a circle. Or one could argue there's an infinite number of sides in a circle, but we won't argue that. So what you want to measure is radius or diameter or something, okay? You have to focus on a linear measurement. Okay, so some straight line measurement. If there's no sides, like in a circle, measure the radius or the diameter. Both should work. So radius is 2 here. Oh boy, 2. Radius here is 1, 2, 3. Looks like. So this one is an enlargement. The second circle is an enlargement. So scale factor is going to be 3 over 2. As a fraction. That as a decimal is 1.5. 1.5 as a percent times 100 is 150%. So something that's 1.5 times as big is 150% larger. Something that is 3/5 of the original is 60% as large. Okay? 100% would be the exact same size. All right, moving on to number 2. I'm going to go quick, so if you can write fast and keep up, then good job for you. Soup's up! Determine if the original will be larger or smaller than the scale. This is for babies. Like literally. This is for babies. You guys can figure this out in the snap of a... Why are my fingers not working? Okay, who's got a good snapper? Come up here and snap by the microphone. Let's see how loud you can be. Come on, right here. Okay. Don't hurt my ears. That wasn't bad. Okay, everybody snap. Let me hear. Oh, it's raining. But what? Now that is a finger snapping talent. You should go on like TalkTick or something and do that. A TikTok. Sorry, you should go on TikTok with that. You get like 1 billion views. Look at this guy snap his fingers. His fingers are almost falling off. It's snapping so hard. Anyways. Okay. It's for babies. Baby question. Determine if the original will be larger or smaller than the scale diagram after the given scale factor is applied. Determine if the original. Okay, so we're going back. So it's not as easy as I thought. But determine if the original. So the scale diagram. So the scale factor is 112%. So you're determining if the original will be a larger or smaller. So that's a bit of a trickier question. It's the wording. So is the original going to be larger or smaller than the scale diagram with a scale factor of 100%, 112%? Original will be smaller than the scale factor diagram because the scale factor is more than 100%. Awesome. So the original, the scale factor of 0.75. So we're going down in size. The original is
bigger.
So this is the original over here. This is the original.
Oh, never mind.
Right? Because we're going scale factor is 0.75. So they took a baby question and they did make it harder. Okay, I'll admit. So the scale factor is 0.75. That means that the diagram is smaller. So the original is going to be, original is bigger. That make sense?
Oh, okay.
Okay. This one, just to go back to this one, the scale factor is 112%. So this is original. This is the diagram. So the original is going to be smaller than the diagram. So smaller, larger or smaller? The original, is it larger or smaller? So for this one, the scale factor is 4/9. That is a fraction. That's a number less than 1, right? So the diagram is going to be smaller than the original. That is, the original is larger. So smaller, bigger, bigger, or larger. So they're asking about they're going back to the original. All right, okay, so that wasn't as easy as I thought it was going to be. Fine. Still, pretty easy for you guys, though, because you guys are pretty smart. All right, question number 4. So 6 and 9, right? So it looks like we're going from, it doesn't matter which is, whatever. So let's go 9, the scale factor is 9/6.
It's 9 meters.
Oh, it's meters and centimeters. Good for you guys. Awesome. So this is actually 900 centimeters then?
Yep.
Cool. Okay. So that's 900 divided by 6 then? Good catch. That's awesome.
That's deceiving.
It is deceiving. So what's 900 divided by 6? $1.50. That's right, 150. Okay, so that means you could take the smaller ones and multiply it by 150 to get the bigger ones. Or you can take the bigger one and divide it by 150 to get the smaller one. That's how multiplication works. Pretty cool. So x is corresponding to 4. So 4 times 150 is going to be what? 600? Now that's actually 6.0 meters. So x equals 6.0 meters. Okay. H, well, let's do y. So y, okay. So I'm going to take, okay, however you want to do this, right? You could do the same thing. 5 times 150 to get this one. So 5 times 150 is what? 750? Or 7.5 meters. You guys are awesome. Okay, so any questions there? You good? Yeah, you with me? Okay. Now, going the other way could be a little trickier. No? Well, let's see. H. Okay, H is going to be, now we said the scale factor going this way is 150, right? Times 150. But coming back is divided by 150. No problem. So let's do 8, now we're going to do centimeters, right? So 800 centimeters divided by 150. So we'll turn that to centimeters, and we'll divide by 150 to get the smaller one. Divided by 150.
5.3.
5.3. Okay, so let's just go 1 decimal place maybe. Nearest tenth of a unit, it says. So 5.3, now that's going to be centimeters. Very good. And finally, G is going to be 600 centimeters divided by 150. And I think that's going to be 400, 400, 4, just 4. So 4 centimeters. Look at that. Easy peasy. Lemon squeezy.
That was easy.
There you go. Soup's up. Get it while it's hot. Okay, anything else? No, not really. 13, there's 13. I don't know. I'm not going to go through it right now, but if you have trouble with 13, watch the video. It's right there. But here's the assignment. 1 to 6, 11, 13, and 17.
Wait,
We dip into a little bit of area here. Wait, is this?
I feel like it's very old.
Yes, question?
For 3, it's kind of like A says determine the scale of the planet, and then 2, determine the second section Honestly, what's the difference?
Good question.